Hello viewers, welcome to my channel Learn with Ravi. In my previous sessions we have seen concepts on numbers, and in this session let us go ahead with the concept of ratio and proportion. I divided this content into multiple videos, so this would be my first video in this concept of ratio and proportion. So let us begin the story. So what is a ratio? When someone says what is a ratio, the straight and simple answer would be ratio is comparison of two or more similar terms or identical variables. Now keep in mind those should be identical terms only. You cannot compare two dissimilar terms. And keep in mind, as ratio is a comparison, as we compare two similar terms, that comparison will not result in any units. So it is an abstract quantity and is dimensionless with no units. Let us take a small example. Assuming that I have Swati and Kriti with some marbles. So Swati puts in 20 marbles and Kriti puts in 60 marbles in a bag. Now, if you want to compare the number of marbles put in by Swati and Kriti, we say it as 20 is to 60. So when you minimize 20 to 60, you get it as 2 is to 6. So we keep in mind that we should always express the ratio in its minimal terms. So a ratio should always be expressed in terms of the smallest possible natural number. If P and Q are two identical terms, then comparing P and Q will result in a ratio, and that comparison can be expressed as follows. So we write P is to Q as P upon Q, P by Q, where P is the numerator in general terms and Q the denominator. Technically we call P as antecedent and Q as the consequent. So when you compare two terms P and Q, we get a fraction, and in that fraction the numerator is technically called as antecedent and the denominator is called as consequent. Okay, so moving ahead, so we have compared two terms. We can also compare more than two terms. So when you compare A, B, C, D, E, we write it as A is to B is to C is to D is to E. Fine with that? So if P is to Q is 2 is to 3, then we can write that as P upon Q is 2 upon 3. Then what is the value of P? We can write the value of P is 2K, and we read it as 2 shades out of 5 shades. Have we got 5 shades? 5 is 2 plus 3. So we have 2 and 3. So 2 plus 3 put together is 5. So the share of P would be 2 out of 5. Similarly, what is the value of Q? The value of Q would be 3 shades or 3K, and we read it as 3 shades out of 5 shades. Is it fine? So then the question is, what is the value of K? So in this case, K is a valid common term. So whenever we have a ratio, each term in the ratio will be expressed in terms of common terms. Is that fine? Now moving ahead. So let us learn the concept of P is to Q, where P is 2K and Q is 3K, and you can write P upon Q as 2K upon 3K, that is 2 upon 3, isn't it? So it is clear that when all the elements in the ratio, if they are multiplied or divided by the same number, then the resulting ratio after the operation will be same as the initial ratio only. That is, the value of the ratio does not change. Take an example. If P is to Q is 2 is to 3, and multiplying by 5 to both the terms, you get 2 times 5 upon 3 times 5. You can minimize 5, so you again get 2 upon 3. Similarly, when you divide a constant called as 5 to both the terms, it is 2 by 5 upon 3 by 5. You are again left with 2 upon 3, which is 2 is to 3. So it is clear that if every term in the ratio is multiplied or divided by the same term, then the final resulting ratio value will be same as the initial ratio value. Is that fine? So moving ahead. So let us see what happens if we compare fractions. So we call it as ratio of fractions. For example, if P is to Q is to R is 2 by 3 is to 4 by 5 is to 5 by 6. Now you have three fractions, 2 upon 3, 4 upon 5, 5 upon 6. So whenever you are told to compare fractions, then you need to convert this fraction ratio into a natural number ratio. How do you do it? We have procedure. The procedure says, in the first step is find the LCM of the consequence or the denominators. Find the LCM of the denominators, and in step 2 we multiply that LCM to all the terms of the ratios. We have seen a minute ago saying that if every term in the ratio is multiplied with the same constant, then the value does not change. So first step is find the LCM, the second step multiply the LCM to all the terms in the ratio. Let us see a small example. In the example, let the LCM of 3, 5, 6 is 30. I hope you all know how to find the LCM. But for the minute, take it as the LCM of 3, 5, 6 is 30. Now, we multiply this 30 to all the terms. So what do you get? 2 by 3 times 30 is to 4 by 5 times 30 is to 5 by 6 times 30. You get the answer as 20 is to 24 is to 25. Now you observe that 2 by 3 is to 4 by 5 is to 5 by 6 has transformed into a natural number ratio, which is 20 is to 24 is to 25. So working with a natural number ratio is easier than working with a fractional ratio. So keep in mind, whenever you are given a fractional ratio, you need to convert that fractional ratio into its equivalent natural number ratio. So moving ahead, so what do you get? For a given ratio A is to B, we have some terms to keep in mind. The first ratio is called as duplicate ratio. So the duplicate ratio of A is to B is A square is to B square. Similarly, the subduplicate ratio of A is to B is square root of A is to square root of B. Okay, so duplicating is squaring, subduplicating is square rooting. Similarly, triplicating the ratio of A is to B would be A cube is to B cube, and subduplicate ratio of A is to B is the cube root of A to the cube root of B. So duplicating is squaring, triplicating is cubing, subduplicating is square rooting, subduplicating is cube rooting. Am I clear to you all? Now let us see the same thing in small examples. The duplicate ratio of 2 is to 3 is 4 is to 9. Have you got 4 is to 9? Square of 2, square of 3, the ratio. So square of 2 is 4, square of 3 is 9. That is 4 is to 9. And the subduplicate ratio of 16 to 25 is square root of 16 is to square root of 25. That is 4 is to 5. If you take the triplicate ratio of 2 is to 3, that is 8 is to 27. Have you got 827? Cube root of 2 is 8, cube root of 3 is 27. Similarly, when you subtriplicate it, the cube root of 64 is 4, the cube root of 125 is 5. Assume that in the given ratio A is to B, if the first term is greater than the second term, if A is greater than B, then adding a term x to both the terms will result in a new ratio, and this new ratio value will be lesser than the actual ratio. Keep in mind that x is greater than 0. Now for example, let A is to B is 3 is to 2 and x is 1. Now when you add 1 to both sides, both the terms, it is 3 plus 1 upon 2 plus 1. That 3 plus 1 is 4, 2 plus 1 is 3. 4 by 3 is the newly obtained ratio and 3 by 2 is the initial ratio. The value of 4 upon 3 is 1.33 and the value of 3 upon 2 is 1 by 5, 1.5. So 1.33 is less than 1.5. So keep in mind, when you multiply or divide, the resulting ratio value will be same as the original ratio value. But when you add or subtract, the new resulting ratio values will have a different value when compared to the initial ratios. So similarly, take another example. If in the ratio A is to B, if the first term is less than the second term, then adding a term x to A and B will result in a ratio which is greater than the original ratio A upon B. So let A is to B is 2 is to 3, and if x is 1, so 2 plus 1 upon 3 plus 1 is 3 upon 4. This 3 by 4 is greater than 2 by 3. How? We have seen the value of 3 by 4 is approximately 0.75 and 2 by 3 is 0.66. So 0.75 is greater than 0.66, isn't it? Now we observe that when both the terms are equal, then adding a constant to both the terms will still result in the same initial ratio. Now, what happens if the value of x is less than 0? If the x is negative, then the inequalities in the above ratios will reverse. What do you mean by that? If a is greater than b, then a minus x by b minus x will be greater than a by b. And in case 2, when a is less than b, then a minus x by b minus x will result in a ratio less than a by b. So the inequalities will get reversed. So that's for now in this first video. We'll see more in the upcoming videos. So put down your thoughts in the comment section and I will always be ready to help you out and share my thoughts. Don't forget to like, share and subscribe. Thank you all.